I'm Al Deering. Welcome. I'm a senior scientist at AURI, and welcome to the AURI Bioindustrial Innovation Center. Today we're here to talk about winter oilseeds. When I talk about winter oilseeds, what I generally be talking about is winter camelina and yellow pennycress. The reason we want to cover these two crops together is oftentimes the processing is very similar for the two, but if you hear me say winter oilseed, basically I'm referring to either one of those two products. Today we're going to be focusing on post-harvest handling of winter oilseeds. The reason this is important is because oftentimes when it comes off of the combine, it contains the chaff and foreign material along with the grain. By removing the chaff and the foreign material, it aids with the storage life because it's going to be reducing moisture that chaff is carrying with it. So today we're going to be taking a look at the processes involved in the steps that we take to get this accomplished. Today we're talking about winter oilseeds and we're here in the lab. The reason we're focusing on winter oilseeds is because they are a crop that can be seeded in the fall, grown over the winter, harvested in the spring, followed by a relay crop or the next crop that you want to plant in the spring. The two that we're primarily focusing on today is yellow pennycress. And yellow pennycress comes in a variety of colors. The original color was actually black. And with breeding and improved genetics, you're seeing more yellow pennycress in the marketplace. The other oilseed we're going to be focusing on today is winter camelina. And you can see that has a different color. One of the key things to keep in mind with winter camelina is that in northern regions, spring camelina is a product that's often grown. In the upper Midwest and in the U.S. here, we are focusing primarily on just winter camelina. One of the key things that we need to do first when seed comes into the lab is get the moisture content. The reason moisture is so important is because you need to lower that moisture content down so it will be preserved or saved if you put it in a grain bin. So what we do is we take a moisture meter, and they come in any different shape and size. You know, we'll load it, we'll get the moisture content, and just like most producers realize, this moisture, we want it to be under 15%. And for these two materials, we often see it ideally under 12% and closer to 10%. That will ensure long-term storage quality. Then following identifying what moisture content it is, if drying is required, we will follow with that process, but oftentimes it's already under 12% moisture. So then comes the separation of the seed from the hull. We do this actually quite easily with these two crops simply by using a 2 millimeter or a 5/32 inch screen. When we get the material in, the seed coat or the hull that the seed is in is about a 1/2 inch in diameter, relatively large. But once you run the materials over a vibrating or a shaker table or a vibrating sieve, the seed easily drops out and separates itself from the hull. The last and final step after sieving the seed is actually doing the final clean to it. Oftentimes, after sieving, that seed still contains some small amounts of foreign material. The way we accomplish this is using an air aspirator. Now, how an aspirator works is, as the feed comes into the aspirator, there's different steps that it'll flow over. That cascades the seed, and at the same time, you have a counterflow of air pulling against it. So the chaff that is lighter and less dense is being pulled up and removed from the seed, and the end result is clean seed coming out the bottom. This can be accomplished through different scales or different sizes of aspirators. As you'll see behind me, there's a much larger aspirator. It operates a little bit different. On this one, you actually have a venturi where you can adjust how that airflow is pulling up through and actually watching the separation occur. What I will do now is actually pour the material through so you can see how it does the separation. And the final result is a very clean seed product ready for storage or further processing. So one of our focuses at AURI is to use the technology we identify and implement it in real-world technologies. With these new oil seeds, there's not a lot of equipment that exists to do the cleaning of the specialty crops. So what we did is we'll work with existing companies that have technology to get the job done. In this case, we worked with a seed cleaner normally used to separate chaff from corn, but in this case with camelina or winter pennycress, the material will come off of the combine through the cleaner, but rather than the grain passing through, the grain falls to the bottom, the chaff carries out the end, and the producer can take the clean grain from the bottom and haul that back to the farm site. So today I'm joined with Paul Novotny. Paul farms in Fillmore County in southeast Minnesota and has tremendous experience dealing with some of these new emerging oilseed crops. So welcome, Paul. One of the questions we wanted to hear from you today is, what are some of the challenges in the production of these materials?
So my first experience with planting camelina is I dove into the relay, the full relay.
Yep.
So it was camelina in the spring, then planting soybeans. Found out right away that I needed to really focus on combine settings. Unfortunately, in the first field that I did was only just a 3-acre spot because most of the things were trials, so I planted 10 acres that first year. Pretty successful harvesting the camelina. Turned out to be a lot dirtier than what I expected, so I had a lot of extra material. So I had a lot of the seed hulls along with the camelina, which turned out to be complicated, trying to get it out of the combine to get into the next, all the next steps. Also realized that in the first year when I harvested that camelina that I didn't have the combine set quite tight enough, blew some camelina out the back of the combine. So lesson learned, if you're going to follow it with another crop that you aren't going to spray anything to kill anything, you could grow camelina and your next crop together. My first time I was probably 50-50 camelina, 50% everything else. Yep. Which was very complicated because I didn't have one of these at the time or any way to clean it, right? So but fortunately I was in a study group, so I sent what I had off, didn't have to deal with it, okay? Year number 2, different story. Year number 2, when I did it, the camelina was mine at that point in time.
Yep.
So a little better job with the combine, didn't lose any, right? But I still ended up with a pretty messy grain tank.
And I think that's quite common, and grain loss, I think a thing for people viewing this to keep in mind is that we're talking about a very small seed here, very similar to what you say almost an alfalfa seed. So when you talk grain loss behind a combine, that's very common. It's very easy to do. So combine settings are hard. So looking forward, as you clean your material, what goals do you have in mind to handle the cleaning coming out of the field this year?
Well, the more people that try it, the more information that comes out. Now I know that maybe I picked a clover setting in my combine.
Yep.
And now I think I'm going to try the rapeseed
Yep.
setting. What I don't know yet is how much you lose in what setting, because obviously we're not harvesting rape, we're harvesting winter camelina.
Right.
So it just all depends. I'm of the mindset that I would rather harvest all the camelina, so I'm on the more side where I'm going to try to collect all the camelina and clean it afterward than to try to have a clean sample and leave some behind. I'm going to try to tighten down the combine, try to get rid of a little less stuff, or a little more stuff, but yet try to accomplish no grain loss.
And I think that's a good goal because oftentimes, number one focus, collect the grain that's out there first. And what we have seen is it is relatively easy to separate the grain from the seed pod and the foreign material. The only issue is you have a lot of mass to deal with at first. But once we can figure out how to easily separate those two, going after the grain first is a great priority.
Well, that's the way I'm looking at it. That's the way I'm approaching it, because you're selling it by the pound.
Yep.
Right. So, I know it's not a lot of money, but it appeared that my first time planting, I left probably 10 pounds on the landscape. Right. Which is when you're harvesting maybe 12 to 1,500
Right.
pounds, leaving 10 pounds behind is not that big of a deal, other than the part of you it's there. So you'll grow it again all by itself. So
Excellent.
I'm going with zero. I'm trying to accomplish zero loss so that I don't leave any behind. Not only for getting it all, but I don't want to grow it again.
So Paul, what is some advice you would give to growers considering growing these new winter oil seeds? What are some hurdles? What have you seen? We'd be interested in hearing your thoughts.
Probably the message that I would say is it's not, if you're a farmer and you're used to harvesting corn, soybeans, you usually generally have the cleanest sample you can possibly get. As it progresses, I think we can get there with combine settings and different combines and maybe different aspects of setting up the combine. But I think right now what I chose to do is I chose to harvest it all. It's a really messy sample in the tank. It's really easy to clean the material after the fact. So go with the mindset of you're not doing anything wrong if it's really messy in the combine and you have a lot of material. There's a way to clean it.
Well, perfect. Well, Paul, we appreciate you coming in today to share some of your history, your knowledge with harvesting these winter oilseed crops, and look forward to working with you in the future.
Yeah, thank you.